This is Geometry, Section 2.2, Conditional Statements. So a conditional statement is an if-then statement. Basically, it's a cause and effect statement. If something happens, then something else happens. So for example, if I study for the test, then I will do well on it. We call this first part, so the part that comes after if, we call that the hypothesis. And the part that comes after then, we call that the conclusion. So a conditional statement is in the form if, hypothesis, then a conclusion. Sometimes you might see it like this, conclusion, and then if in the middle, and then the hypothesis at the end. You won't see that a lot, but sometimes you might. A counterexample is a specific example that can be used to show a conditional statement is false. So if we have a statement, we've got some examples down here. Letter A says, if your name begins with A, then your name is Annie. Obviously that's a false statement. A counterexample would be that your name is Alex, because Alex starts with an A. So the first part says if your name begins with A, well, Alex starts with an A. It says then your name is Annie. Well, Alex is not the same as Annie, so this would be a counterexample showing that that statement is false. Second one, if the month ends with Ember, then it is September. Counterexample would be it could be November or December. That shows that that statement is false. Letter C, if the hangman word is blank, O-N-K-E-Y, then the first letter has to be M. That's false. The first letter could be D. You could be trying to spell the word donkey. So a counterexample can only be used to show that a conditional statement is false. There's no such thing as one statement that can show a conditional statement is true, but a counterexample definitely shows that it is false. A converse of a conditional statement. So a converse is where we take the conditional statement and we switch it around. So this would be if the conclusion, then the hypothesis. So for example, if I have the conditional statement, if it is 2008, then it is a leap year. First of all, that's a true statement, because 2008 was a leap year. So that's a true statement. If I want to take the converse of that statement, I just switch it around. I say, if it is a leap year, then it is 2008. So I just switch the hypothesis and the conclusion around. I keep if and then where they are, and I switch the hypothesis and the conclusion. This statement is actually false. So if we look down here, it says, note that the truth of a conditional statement and the truth of its converse are not always the same. So one could be true, one could be false, or vice versa. They could be the same, but they don't have to be. If it is the weekend, then it is Sunday. This is a false statement because it could be Saturday. If it's the weekend, it could be Saturday, it could be Friday. So that's a false statement. If we took the converse, we would switch that around. If it is Sunday, then it's the weekend. That is a true statement because Sunday always falls on a weekend. Last one, if measure of angle y equals 90 degrees, then angle y is a right angle. That's a true statement because a 90-degree angle is a right angle. If I switch it around for the converse, if angle y is a right angle, then measure of angle y equals 90 degrees. That is also true. That's a statement that's true both ways. So, the word negation. So if I want to negate a statement, that basically means to say the opposite of it. Okay, so if I have the statement, I am a student, the negation of that statement would be, I am not a student. If I wanted to negate the statement, Monday is a weekday, I would say Monday is not a weekday. We're making that statement negative. We're saying the negative of that statement. X is less than or equal to 5. That would be X is greater than 5, because if it's not less than or equal to 5, it must be greater than 5. So the inverse of a conditional statement, we talked about converse. Inverse is another way we can modify a conditional statement. So the inverse is if we negate the hypothesis and the conclusion. We keep the order the same. Okay, so with a converse, we switch the order of the statements. With an inverse, we're going to negate both pieces, but we're going to keep the order the same. So hypothesis first, conclusion second. So if we have the same three statements, if it's 2008, then it's a leap year. To write the inverse of this, we're going to say if it is not 2008, then it is not a leap year. If it's not 2008, then it's not a leap year. That would be a false statement because it could be 2012. So if it's not 2008, it could be 2012, but that is a leap year. So this statement says it's not a leap year. That would make it false. Next one, if it's the weekend, then it's Sunday. The inverse would be if it is not the weekend, then it is not Sunday. That would also be a true statement, just like the converse was. So if it's not the weekend, then it's not Sunday. Obviously, if it's not the weekend, then it has to be a weekday, Monday, Tuesday, Wednesday, Thursday, or Friday, so therefore it can't be Sunday. If the measure of angle y is 90 degrees, then angle y is a right angle. Inverse would be if the measure of angle y does not equal 90 degrees, then angle y is not a right angle. That would be true, because if it's not 90 degrees, then it can't be a right angle. A right angle has to be 90 degrees. So last thing, the contrapositive. So we've talked about converse, inverse. Now what's the contrapositive? So a contrapositive is where we do both things. So we're going to switch and negate the hypothesis and conclusion. So we're going to do both things, a combination of both things that we just did. So same three statements. If it's 2008, then it's a leap year. Contrapositive, we're going to switch the order and we're going to negate both pieces. So if it is not a leap year, then it is not 2008. So original statement was if it's 2008, then it's a leap year. Contrapositive would be if it is not a leap year, then it is not 2008. Would that statement be true or false? Well, if it's not a leap year, then it can't be 2008 because the original statement we had said if it's 2008, then it's a leap year, and that was a true statement. So obviously if it's not a leap year, it can't be 2008 because we know 2008 was a leap year. If it's the weekend, then it's Sunday. So flip it around and negate it. So if it is not Sunday, then it is not the weekend. Is that true or false? Well, if it's not Sunday, it could be Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. So it says if it's not Sunday, then it's not the weekend. Well, it could be Saturday, and Saturday is the weekend, so this would be false. If the measure of angle y equals 90 degrees, then angle y is a right angle. Flip it around. If it is not a right angle, then it is not 90 degrees. Again, that would be true because it can't be a right angle if it's not 90 degrees. Note that the truth of a conditional statement and the contrapositive are always the same. So if one is false, the other's false. If one is true, the other's true. So this was a this was a true statement. If it's 2008 and it's a leap year, that was a true statement. This also should be a true statement. Sorry about that. If it's not a leap year, then it's not 2008. That's true, because if it's not a leap year, then it can't be 2008. We know 2008 was a leap year. That should have been true. Sorry about that. If it's the weekend, then it's Sunday. We said that that was false because it could be Saturday. Contrapositive is also false. If measuring a y of 90 degrees, then it's a right angle. That was true. The contrapositive is also true. So, just to sum everything up, if we have a conditional statement, if A, then B, the converse would be if B, then A. We're just going to switch the hypothesis and conclusion. The inverse, we keep the order the same, but we negate those things. So if not A, then not B. Negate hypothesis and conclusion. Contrapositive, we do both. So if not B, then not A. So we switch and negate hypothesis and conclusion. So, a few more. Our original conditional statement, if our original conditional statement is if today is Thanksgiving, then today is Thursday. To write the converse, we switch that. So, and this is a true statement, if today is Thanksgiving, then today is Thursday, because Thanksgiving always falls on a Thursday. The converse would be if today is Thursday, then it is Thanksgiving. That is not a true statement because not every Thursday is Thanksgiving. The inverse would be if today is not Thanksgiving, then today is not Thursday. Again, that would be false because there's a lot of Thursdays that are not Thanksgiving. So if today is not Thanksgiving, it doesn't necessarily mean that today is not Thursday. The contrapositive, flip it and negate it. So if today is not Thursday, then today is not Thanksgiving. Remember that the original statement, if the original statement is true, the contrapositive is automatically true. If we look at this, if today is not Thursday, so we're assuming it's not a Thursday, then today is not Thanksgiving. That would be true because if today is not a Thursday, it can't be Thanksgiving since Thanksgiving always falls on a Thursday. This one, if x is odd, then x equals 17. That's a false statement because there are many other odd numbers besides 17. So if x is odd, x doesn't necessarily have to be 17. The converse, switch it around, if x equals 17, then x is odd. That is true. If it's 17, then it's an odd number. Inverse, keep the order the same, but negate both statements. So if x is not odd, then x does not equal 17. So assuming x is not an odd number, then x cannot equal 17. That's true, because if it's not odd, it obviously doesn't equal 17, since 17 is an odd number. Contrapositive, if x does not equal 17, then x is not an odd number. Note that the original statement was false, so the contrapositive automatically has to be false. If x is not 17, well, x could be any other number besides 17. It's saying if this happens, then x is not an odd number. Well, there's a lot of other odd numbers that are not 17, so this is not a true statement. So, note that the conditional, the original statement, and the contrapositive always have the same truth value, meaning that if one is true, the other is true. If one is false, the other is false. So we already kind of talked about that. Also, it's important to notice that the converse and inverse, the same thing happens with those. They have the same truth value. So if one of those is false, the other is false. If one is true, the other is true. You can notice that here and here, or also for any of the other examples that we talked about.